Figure says its humanoid robots contributed to the production of more than 30,000 BMW X3s. The footage is real. The factory is real. And this time, unlike many humanoid demos, the robot did cross into live production. But the headline can create a much larger picture than the evidence supports. Figure 02 did not build 30,000 cars. It loaded 3 sheet metal parts into a welding fixture before conventional industrial robots performed the welding. That is a genuine production task. It is also one narrow station in a highly automated factory. So the question is not whether the robot moved. It did. The question is what this deployment actually proved about autonomy, reliability, scale, and commercial value. The story began in January 2024 when Figure and BMW announced a milestone-based commercial agreement. The language mattered. First, Figure would identify possible use cases. Then robots would move through stage deployment. It was not a promise of an instant fleet. In the summer of 2024, BMW ran a several-week trial at Plant Spartanburg. Figure 02 inserted sheet metal parts into fixtures in the body shop. BMW called the test successful, but also said that, as of August 6th, no Figure robots remained at the plant and no definite return timetable had been established. This was progress on a ladder: agreement, trial, evaluation, then a possible production phase. Public discussion often compressed those stages into one word: deployment, even though each stage required different evidence. Strip away the humanoid silhouette, and the job becomes easier to audit. A rack presents sheet metal parts. The robot approaches, grasps a part with 2 hands, carries it to a contained work cell, aligns it inside a fixture, releases it, and repeats the sequence. After loading, 6-axis industrial robots weld the parts and feed them into the main line. Figure says the full station requirement was 84 seconds, including a 37-second loading phase. The placement tolerance was 5 millimeters. This is not a staged coffee-making trick. It is a real material handling problem with locomotion, manipulation, timing, and integration constraints. But it is also structured pick-and-place. The useful achievement is not that a human-shaped machine stood in a BMW factory. It is that the machine repeatedly completed a defined transfer inside an existing production system. In November 2024, Figure published an update saying its autonomous fleet was 4 times faster, with a 7 times higher success rate and 1,000 placements per day. But the same thread explained that these robots were running on physical and digital twins that replicated customer environments. 3 months earlier, BMW had said there were no Figure robots at the plant. The update showed technical progress, but it did not establish sustained production at BMW. Then, in February 2025, Figure's chief executive wrote that a fleet was performing end-to-end operations for BMW. Fortune asked BMW what that meant. BMW said there was 1 Figure robot working at any given time, practicing 1 limited pick-and-place task, initially during non-production hours. That does not make the technology fake. It makes the public framing materially broader than the customer's description at that moment. The most important correction cuts in the other direction. By early April 2025, BMW told Fortune that the same limited task had moved into live production hours. Later, both companies described a longer deployment. Figure reported 11 months for the overall project. BMW described 10 months of production support. In June 2026, BMW confirmed that Figure 02 had inserted sheet metal parts for welding and supported the production of more than 30,000 X3 vehicles. That customer-side confirmation matters. It moves the result beyond a company demo and beyond an off-hours test. At least 1 robot performed useful work on an active automotive line. The bounded verdict must preserve both facts. Figure crossed the line into production, and the verified scope remained much narrower than a general-purpose fleet performing end-to-end factory operations. Figure published 3 large totals: more than 90,000 parts, more than 1,250 hours of runtime, and 10-hour weekday shifts. BMW later repeated those figures in its own reporting. They are meaningful, but they are not the denominator needed to verify line performance. 90,000 parts divided by 1,250 hours equals 72 parts per hour. If a complete cycle uses 3 parts, that is about 24 cycles per hour, or roughly 150 seconds per cycle. The stated station requirement was 84 seconds. That gap does not prove a failure. Runtime may include setup, pauses, recovery, maintenance, or multiple robot hours. The station may not run on every vehicle. The point is simpler. Aggregate totals cannot reveal the cycle time distribution. Figure published the target. More than 99% placement accuracy and 0 human pauses or resets per shift, but not the achieved shift-level results. Figure describes the work as autonomous. Public video shows the robot executing the sequence without a visible person steering each motion. That is evidence of automated behavior, but it does not define the control boundary. Who selected the task? Who started each cycle? What happened after a bad grasp? Could a remote operator reset the system, reposition an object, or recover the robot? Figure's early deployment plan explicitly included teleoperation as one tool for training and helping robots out of jams. That does not prove production cycles were teleoperated. It proves that teleoperation existed somewhere in the development and recovery stack. Without control logs, intervention counts, and recovery records, the public evidence cannot distinguish autonomous execution with supervision from autonomous recovery. The safe status is not manual and not fully independent. It is, autonomy claimed, control boundary unknown. BMW says the pilot demonstrated that humanoid robots can safely perform precise, repeatable work under real production conditions. That is an important operator statement. But the public record does not include incident counts, near misses, emergency stops, force limits, or the risk assessment. Fortune described the robot working inside a contained cell, a more limited safety proposition than unrestricted collaboration beside people. The economic case is even less visible. The contract price, robot count, integration cost, supervision burden, maintenance, downtime, and cost per part remain undisclosed. In June 2025, when asked whether the BMW relationship was a pilot or had commercial value, Figure's chief executive emphasized the learning value but did not provide contract specifics. Productive work is verified. Profitable work is not publicly established. So what did Figure actually prove? First, a humanoid robot can perform a precise, repetitive sheet metal loading task inside a live automotive production system. Second, the deployment lasted long enough for BMW to connect it to more than 30,000 vehicles. Third, real factory use exposed hardware weaknesses. Figure identified the forearm as its leading failure point and redesigned the wrist electronics for the next generation. What did it not prove publicly? A broad fleet performing multiple end-to-end operations. Published success and intervention rates. Autonomous recovery. A cost advantage over fixed automation, mobile manipulators, or human labor. The most accurate verdict is neither demo nor revolution. It was a real production deployment with narrow scope, valuable operating experience, and an evidence package that still stops short of proving general-purpose autonomous labor at scale. Figure 02 has now been retired, and Figure 03 has arrived at BMW for a new logistics and sequencing workflow. The new footage shows bin picking, parts sorting, locomotion, and trolley handling. It is a promising next step, but at the research cutoff it remains a first demonstration, not a published production result. The next audit should be easy to satisfy. Release the number of robots, every cycle, the cycle time distribution, success rate, human interventions, autonomous recovery rate, downtime, safety events, and cost per useful part. Until then, the BMW project deserves credit for crossing from lab footage into production and scrutiny for every conclusion that travels beyond the disclosed data. This is the machine audit. Follow the evidence, not the silhouette. Thank you for watching. Subscribe to stay with the next deployment.